Okay, I think we're at time, so we'll get started. So, hi everyone, my name's Patrick Lucey. I'm Chief Scientist at Stats Perform, and today I'm going to talk about how we apply generative AI to sport, and the opportunities that are there, but also some key considerations. So, Stats Perform, what do we do? So, you probably haven't heard of us, but if you are a sports fan, you probably touch us every day. So if you Googled the Champions League games last night, the score, have you ever thought where that data comes from? Well, that comes from us. If you ask Apple or Amazon Alexa any question, that comes from us. You're probably more familiar with our data brand, Opta, the deepest treasure trove of data out there, the most reliable data source out there as well. So that's us. Okay, we're based here in London, beautiful office in Paddington. We're a global company. So basically what we do, we're the keeper of public record. We collect that data using computer vision and humans. And then also we do a lot of AI on top of that. If you watch the Champions League highlights last night on BBC, we're powering a lot of the analysis, but also using our predictive content. So in the sports ecosystem, essentially, we power everything within that ecosystem. So whether that is team performance, whether that's media and broadcast, whether that's betting, we drive all that. And we drive that two ways. Number one is data generation. So we use artificial intelligence to generate that. And also we help the consumption of that data. And so that's really what I'm going to talk about today. Okay. So at this great conference, a lot of people here, everybody talks about generative AI. And so that's a lot happening in the last 3 months or so. People will be familiar with OpenAI, GPT-4. Google, the day after, at the I/O conference, had a lot of new innovations, Circle to Search. Apple Intelligence with the new iPhone, you're able to interact with your private data. Meta has their new large language model out there, open source, and more recently with Search GPT, and last week with OpenAI O1. Okay, so there's a lot happening. And so really what I want to do today is connect what's happening outside of sport to what we do in sport. Okay? So with all these announcements, people love sport, that's why you're here. Sport is a great connector. I gave a keynote at European Conference in Machine Learning last week. I was in Lithuania. I hadn't been there before, but I knew about the basketball team, the 92 other dream team. And so it's a shared language. So sport is so powerful because it brings people together. It's one of the few things that we have in common, and it's live and it's shareable. Okay? So tech companies like to use sport as an example. A recent example, so someone from OpenAI said, well, the next thing that we want to do with ChatGPT is hold it up, watch a game, and get it to explain the rules of soccer to us. Okay? Seems pretty cool. So let's use that as an example. So we have the Champions League final back in May, Borussia Dortmund versus Real Madrid. Okay, so Real Madrid are up 1-0. It's around the 82nd minute. So Dortmund have the ball. Ball gets turned over. Jude Bellingham gets the ball. Passes to Vinicius Jr. It's 2-0. So as sports fans, at that moment, do you want to pull out your phone and say, explain the rules of soccer to me now? Okay? The answer is no. Okay, we have our 10, 20,000 hours worth of experience. We have that language. We understand football. As a fan, the type of questions that you want are, was this a good chance? Who was dominating play at that time? Who's going to win? How much time is left? With stoppage time, VAR. So we can actually answer that using our event data, but we can be more granular. So I'll get into the language of sport, because at Stats Perform, we are generating this language of sport. So using tracking data, we can say, well, how often have Real Madrid done this? What formation is that team playing? Which role is Jude Bellingham playing at that moment? Who should have that player from Borussia Dortmund passed to? Where should have the defender been? And we can actually answer those questions via tracking data. Now with generative AI, we can ask broader questions such as, prediction. I'll showcase how we can do predictions, such as how many shots would Vinicius Jr. have or Bellingham have in terms of assists. We can ask the question in terms of recruitment. Find me a player like Vinicius Jr. Okay, who's under 21, and let's recruit him. And can we ask those questions in natural language? So that's how we can lean into generative AI. So really, the three things that I want you to take away today is that in terms of everything that people do, I think IBM noted that less than 1% of enterprise data is kind of powering these large language models. The next wave is to use proprietary data to create your own language. And that's what we've been doing at Stats Perform over the last 10 years. And we can do that via event data, tracking data, and then we can use the great enablement, or generative AI is a great enabler, and we can do a lot of things like that. So to kind of tie that to intuition, so a lot of the large language models that people are utilizing now commercially, they're anchored to text. So text is the backbone of knowledge, and we can augment that with images, video, and audio, okay? So you can think of this as basically general knowledge. Now for sport, like the medical field or the finance field, is very granular. It has its own language. It's objective and uniform. And the backbone of knowledge there is our Opta data, our event data, telling us what happened on each ball or each event. And then we can augment that with our tracking data as well. And then once we've formed that language, we can do language modeling, but also we can interrogate that data. So what do I mean by that? So one thing which is very popular, so we brought in expected goal values 10 years ago. And so the idea with XG is instead of knowing if a shot was successful or not, we can tell you the quality of the shot or the quality of the chance based on the contextual features, such as whether defenders are, the goalkeeper, whether the player had the shot with the left or right foot or the head, the clarity, whether their back was to goal or not, all that information. And so instead of saying, well, this team had 20 shots, we know if they were good shots, okay? So if you go back to the Champions League final, Borussia Dortmund absolutely dominated the first half, okay? Courtois had a very good game, but Dortmund had very, very good chances. We can quantify that. Now, we can go beyond that with something called possession value. So instead of shots, we can value each action. So if you watch the Premier League broadcast, you'll probably see something called momentum. And so we can actually see how dangerous each action is, leading to shots and goals. Okay? So we provide that. So here you have a visualization showing that, yes, Dortmund dominated that first half, but they didn't convert. In the second half, Real Madrid dominated. Okay? The nice thing, also, we have live win probability, which is like table stakes. So that's a prediction. We use supervised learning to do that. We have season simulation. So if you follow anything, we call it the Opta supercomputer. We rate Manchester City very, very highly. So this was an update after the weekend in terms of where we think how many points each team's going to get and where they're going to finish. Then obviously with the language, especially in terms of football, it's how long the game's going to last. With VAR, injuries, stoppage time is varying, and it's even more. It's not just 3 minutes, it can be 10, 20 minutes now. Okay. We can actually do this across all sports. So we do this for tennis. So if you watch a WTA, we do this at the granular level, but also we do it at the tournament level. If you watch the Rugby World Cup, you saw those metrics, the kick predictor, momentum, we generated that. We do this for cricket. We do this across all US sports, okay? Great thing working at Stats Perform, or our Opta, is that we do this across all sports, and we do this live. Now, that's one part, okay? But sport is bimodal. It's multimodal, okay? So here in the UK, you've probably played Subbuteo, or you see Pep Guardiola with the magnets, he's moving it around. You know, it's visual. It's very complex. So what do I mean by that? Well, video is the kernel of all knowledge. So I watched an excellent documentary last night. It was a bit jet-lagged. It was about Kylian Mbappe, okay? So let's just say when he was at PSG, he's down the right-hand side, and we stopped. Imagine in terms of querying, we could ask the question, how often have they done that? How often has Kylian Mbappe run that play? So how would we articulate that by words? Well, a picture tells 1,000 words, okay? So that's the fundamental question. Now, if we think about what tracking data is representing what we see in pixels to these dots. And tracking data has actually been around for 25 years, okay? We started that in 1998. It's an ultimate compression. It's a 1,000,000 to 1 compression of what you see the pixels to these dots. And so that's a way that we can get a computer to understand the X's and O's. So imagine if I had that play, and instead of using words, I could have a visual prompt. I could say, find me all the things like that, okay, and have that example. And I drop that in, and I click a button. So instead of that taking a couple of days' work just to find a similar play, we can do that in a matter of seconds, okay? We can have those plays. You can think of this as YouTube for sport, okay? From that too, we can actually analyze every decision a player makes. So just say we have a pass. Did that player make the good pass? So I think a lot of football fans will be saying, well, pass completion, a player passing side to side, really doesn't tell the story. We want to know if it's a penetrating pass. So using supervised learning, we can actually do that. We can quantify the likelihood of a pass being completed, the likelihood of that pass leading to a shot in the next 10 seconds. Also, we can measure if a player is available. So again, we can do those measurements. We can do formation. We can detect which formation a team is in, but also which role a player is in every frame. So again, if you watch the Champions League final from last year, from May, Toni Kroos, it was his last game for Real Madrid. He's basically like a quarterback. When he gets the ball, he drops to the far left. Now we can do those type of measurements instead of it being subjective, okay? Also, some pioneering work that we've done is the idea of ghosting, okay? So here you're seeing red as the attacking team, blue as the defensive team, and yellow as the ball. What you're seeing there in white is our models predicting where the play should have been to minimize the expected goal value, okay? We call this imitation learning. It's popular in robotics, but essentially we're imitating or emulating what teams should have done in that situation. And the nice thing is that we can do this across all sports. So on the right there, you can see basketball. So imagine, I get very excited about this concept, you could say, well, find me that play. What's the likelihood of that player scoring that position? Like a video game, imagine if I move that player around. What happens if I move that defender around? Or what happens if I switch, the counterfactual question, a player with another player? Okay, we have that interaction via video games, but now we can do that with real data. We have a partnership with Tennis Australia. So during the last Australian Open, we come up with this idea of predicting where the next shot is going before it's been played. We have a personalised model where we can actually predict that accurately. So now that we've established that the language is bimodal, it's the event data and our tracking data, how can we utilise that content more? So one thing is actually we can do better predictions. So once we've established that language, how can we actually utilise that more? So a lot of you will know this, generative AI, the genesis was really around these transformer neural networks. So language modeling is just predicting the next word. So I have this sentence, the most likely next word is apple, okay? Now that's based on this paper, Attention is All You Need, which most people know, but really the intuition is that we can contextualize data better, okay? Now, I have a very simple example here. The reason I'm showing this is get a very simple example here and see how we can apply this to sport. So we have this first sentence, the man deposited money at the bank. A way we can get a computer to understand that is by tokenizing. And then we have another sentence, the man sat on the bank of a river. We have two sentences here. They have the word bank in them both, but they have different meaning. And the way that we know it's a different meaning is by looking at the different words in that sentence. Okay? And so with these transformer neural networks, we can contextualize this better. Now, how do we apply this to sport? Okay? So let's use an example such as Manchester City. I think this example I took from last year. So instead of a way that we can represent it at the team levels, have the goalkeeper all the way up to the striker. Okay? So and we can tokenize that by representing each player by their historical performances. Okay? We use an Opta database. We see what they did in the previous matches. Now, previously, we couldn't model the per-player interactions with the other players and the opponents. By doing this, such as Haaland scoring 50 goals a season, he's a very, very strong word. Okay, so he's going to impact everyone else. So using this approach, we can actually do better player predictions, which is really, really powerful when we're talking about how we can do within match predictions. So just say there's a red card or a key player is injured or substituted, we can actually do far more accurate predictions there. Okay. Another thing that we can use generative AI for is to actually complete tracking data. Okay, so as I mentioned, tracking data has been around for 25 years. The problem is that it doesn't scale because you need to be in venue. One way to get around that is to use the video that we watch at home, okay, which is great. You know, we have a goal of digitizing, creating tracking data from every game that's been played. A problem is that not all the players are in view, okay? Half the players are out of view. Then we get the situation when the director or producer does a close-up, which means that we have incomplete data. We can't track those segments. Now remember that video is, tracking data is our video and event data is our text. We basically have created our own SORA model, text to video. So here we have broadcast video. On the top there you have our broadcast tracking, and then below we have our event data. Using our generative model, using diffusion, we can actually provide complete data. So even though it's close up, we don't get broadcast tracking, we can see what happened before and what's happened after with the event data, and we can actually generate complete data, okay? I think it's pretty cool, and the power of that is that we can actually analyze every pass that's been played. Obviously very important for recruitment, but also if you do an analysis of these historical players, that's super powerful. Now, we've been doing AI for a very long time. I started the AI group about 10 years ago, and a lot of the content that you actually consume is already being generated automatically, okay? So we're B2B business. A lot of our customers use a product called Opta AI Studio, where we're generating the insights, the visualizations, and our customers are actually surfacing that. Another way that people are consuming our data is via something called Opta Stream, where we're just generating an automatic stream for people to interact with our data. A really good example of how Vodafone used that and got more user engagement. Again, we do this across all sports. Another way people are consuming data is via stories, you know, with Instagram and TikTok, where we can actually provide a nice stream where people can consume the story of the match. Now, in terms of sport, there are 3 different stories that we can tell. We can tell the story before the match. Obviously, we can tell the story live. And then we can tell the story post-match. And again, we're automatically generating this content. Also, betting is probably the biggest engagement tool out there. And so if you do bet, if you look at a stream, we provide those streams to sportsbooks, those low latency streams. But also, the video is a canvas, so we can generate overlays, we can generate opportunities for people to interact with that data. And so that is a way that you can engage and personalize more. I mentioned in terms of our predictions, so Opta points. So because we have so much information out there, we can combine this, bundle this up into one rating where people can actually bet, or it can lend itself to gamification, and we can use our predictive models underneath to set the lines, but also enable this other engagement as well. So we have a lot of our sportsbook partners using that. So if you're watching the games this weekend, you see these markets, just know that we're behind the curtain generating that. So the reason why we're generating all of this automatically is because sport is live and you don't have time to query, right? When something happens, you need to trigger that automatically, and so we call that pushing information out. But also, there's the opportunity with pulling information. So obviously, with generative AI now, ChatGPT, you can interact. You can ask your questions in natural language, and you can get the answer that you want. Now, over the weekend, if you're watching sport, if you're using ChatGPT or Gemini or something else, you will realize that there's a lot of hallucinations there. Okay, don't use that technology for sport because it's going to be wrong. Okay, because they don't have access to our data, because our sports data is live and dynamic, and so it's problematic. So what we have created is this nice tool internally for us to interact with all our live data. So we call this Opta AI Chat, where we can actually put in any question. I think the example that I show here is from a Champions League game, and we can actually pull that up, and we can ask to do a recap, You can ask for visualizations. So a lot of those different things that I showcased, we can actually do in this one application. So this is just internal to showcase all the great content that we have, because again, we're not direct to consumer, and so we don't have all the different questions that people at home would ask, and obviously the natural guardrails that you need to put in place there. So that's a whirlwind, so a lot of content there, but I just wanted to showcase what we're doing at Stats Perform, especially around our Opta AI initiative, doing a lot of great work. So now if you see metrics, if you see content, you know where that is coming from, okay? So just 3 takeaways is that a key thing that we do, we collect data, but we have to create the language, okay? So we have to create the language of sport, and we've been doing that for a long period of time. We do that via event data and our AI models. We can measure, we can do that via tracking data as well, and then also we can leverage our generative AI models as well. So I think we have a bit of time left, so that's all I had to show to everyone today. So I'll stop there. Thank you for your attention. If you have any questions, I think I'll be happy to answer a couple of questions. So thank you. Yep. Yeah, if you say, I'll repeat it. Yep. Yeah. So the question is, are other sports harder to predict than are some sports harder to predict than others? So the answer is yes. So if you think about football, you know, tracking data in soccer has been around for 25 years, but because of the nature of football, it's low scoring and it's continuous, right? So that makes it difficult. If you look at the US sports, so Moneyball, our company actually started with the Moneyball revolution, 1981. Bill James, whose formula were basically used by Billy Bean. You know, he was part of the grassroots campaign that started us. So US sports are a lot easier because it's segmented. That unit of analysis, such as a play or a possession, is easy to analyze. If you think about basketball and American football, they're higher scoring. So that lends itself to having that label to find those correlations. Now with soccer, even though it is the global game, there's a lot more games, there's 13,500 professional teams. It's difficult because of those nuances. It's low scoring, but I think we've done a really good job, especially the last 10 years, and hopefully in the next year or so, you'll see a lot of these new innovations and enabling people at home to actually interact and ask those questions themselves. Yeah. Other question? Yep. You can just ask and I'll repeat it.
I was just going to ask whether there's, what's the one thing that you can't track at the moment that you think would be really helpful?
So the question is, what's the one thing that we can't track but would be very helpful? So tracking data, as I mentioned a couple of times now, has been around for a very long period of time. That's center of mass, it's mass compression. So where computer vision technology is going is through body pose analysis. So you can have like 28 points, or you could go to 7,000 points, which is giving a deep mesh. Now, a lot of these things, and looking at eye gaze and whatnot, in sport, there's going to be natural guardrails. So if you look at heart rate and things like that, that would be super useful in terms of measuring fatigue. However, there'll be natural guardrails in place, which means even though we like that data, we shouldn't get it, because we're the keeper of public record. Now, this is an opportunity, however, because teams could actually get that private data, and I see the future opportunity is merging that public data, public analysis that we're providing, with private data, which teams have their own IP, can manage. So that would dovetail nicely to the other private data, such as training, contract, psychological, medical information. So there is that other aspect, but I think there are natural guardrails in place, which there should be, but then there is opportunities for these teams to leverage that to actually contextualize performance better, right? Because a lot of things are hidden. We don't know the coach's strategy, especially if they're playing in 4 competitions. Are they resting a player because he's unwell, kids are sick, or they're resting for the Champions League or the FA Cup, or they want to bring through a new academy player? They're all those things that are hidden, which we'd like to get, but those natural guardrails are in place. But excellent question. Thank you. Management. So the question is, do we do anything in terms of predicting management? So we don't currently. So obviously we're generating a lot of descriptive metrics. So we can describe how teams are playing, which could be used to profile a manager. Now, if you look at some very successful clubs, kind of using the Moneyball approach, such as Brighton, they always seem to find these hidden gems in terms of managers. So they had De Zerbi, and then they brought in this new German manager who was 31. And so teams are often doing that, but that also links to the private conversations. So budget. So we don't know budget. We don't know the aims of the owners. The style of play. So you look at Tottenham Hotspur bringing in Ange Postecoglou. There's a certain style of play that they want to adhere to. So teams do that, but I think that's kind of more to the private nature of the data in that information. Yeah. Yep. So the question is there a point where the data that we collect is irrelevant? The answer is yes. Obviously, there's data drift. If you go to data, yes and no. Okay, so if you look at the history of football, there are rule changes. So if you look at the pass-back rule in 1992, so that's obviously a key thing in the change of game. More recently, if you look at VAR, if you look at the 5 substitutions, okay? So the game is evolving. So we need to be able to map the language or update the language. Like the human language evolves, there's new words that get into the dictionary, grammar evolves. So we need to know how we update that, how we kind of adapt to it. There's different styles and leagues. Now there are the financial fair play. So that's coming into consideration where teams have to analyse decisions better. So as you know, you don't want to do any harm to the data. It's often to have better, more data than not. And then it's up to the practitioners to create that language. And once you have that, you let the model to decide. But you do need that subject matter expertise because the models don't know football. They don't know the rule changes. You need that subject matter expert to basically enforce those constraints. And so that's where it really comes in, where you set the grammar and the vocabulary and also inject in that domain knowledge to make sure that it's not overfitting to old rules, right? Yeah. Question? Yep. So the question is the plan to scale to smaller teams, to academies? So that's the great promise of artificial intelligence, and something that I didn't talk about, but as a father of 2 young girls, democratising analysis to the women's game. So obviously the Lionesses are doing very well, the rise of the Premier League, the Women's Premier League, just top-tier football here in Europe. So the answer is yes, but again, it's those natural guardrails. So we are the keeper of public record. Where those games are played, we can capture that and we can scale that out. At the academy level, we do collect that data, but there are different constraints. People ask me about training as well. Training is very unstructured, depending on where they are. If the manager or the coach is saying it's 4-on-4, 3-on-3, there could be specific instructions that we don't know. That makes it very difficult. So I think the next phase is 2 things. Scale it to women's sports, and that is rapidly professionalising. Initially, if you look at women's cricket, there's a lot of variance, but given more games are being played, it's getting very, very more tightly correlated in terms of performance. In terms of, and then also enabling other teams or the lower teams to kind of use what we've created and basically stand on our shoulders to answer the questions that they previously couldn't answer. But in terms of academy, I think that's kind of the unstructured nature makes it difficult, but I think the next step is democratizing for people at home and to these smaller teams where we have that data. Yep. Yep, so there's 1 minute left, so this will be the last question. You can follow up with me afterwards. Yeah. So the question is, do teams use real-time data to make decisions? Now, it's a very interesting question. So now you're seeing tablets on the side of the pitch. So obviously they're getting that input. It's all about communication too. So the art of communicating these key things to coaches, otherwise you'll be kicked out, relaying the right information. If you look at US sports, it's becoming now a thing. Previously with the league associations, you weren't able to do it. So the NFL, Major League Baseball didn't allow any technology on the side of the court. But now with sponsorship, they're injecting that more. But you are seeing this more and more, but you have to be very careful because it's a trust thing. If it gets it wrong once, you could actually take 2 steps backwards. So in terms of practitioners, you know, the ultimate robots, the ultimate AI are the coaches. They know this. And the data that we have is just a compression of what they see. So we just want to augment that. But you'll see that, but it's really human and computer together. We just need to be careful. Practitioners just need to know how to communicate, distill that, and don't lose trust. Yeah. So I think we're at time. So I appreciate everyone's attention. Enjoy the rest of the conference. Thank you.